Tangent theta equals root 2 over 4. Quadrant 1 only. That's going to make life a little easier. Cosine theta over 2 is what I need to find. So, first things first, it's giving me tangent theta equals stuff. Let's do SOHCAHTOA stuff. SOHCAHTOA stuff. Tangent means opposite over adjacent. So if I were to draw some arbitrary right triangle like so and put some regular theta like so, my opposite's going to be root 2, my adjacent's going to be 4. I need to find cosine. Cosine is adjacent over hypotenuse. I don't have my hypotenuse. Let's find it using good old Pythagorean theorem. A squared plus b squared equals c squared. So I guess I'll call you A, I'll call you B, not that it really matters. 4 squared plus root 2 squared equals c squared. 4 squared, 16. Root 2 squared is 2. Add those up. Square root it. 18 is 2 times 3 times 3, so I can rip a 3 out, and I'm left with 3 root 2, and that's my c, and that's my hypotenuse. Now, that's great. And what all of this means is cos theta is going to be my adjacent over my hypotenuse, my 4 over 3 root 2. Multiply the top and the bottom by root 2 because you know it's illegal. I'm going to wave my hands a little bit to save a little bit of time because time is money. And I need the space too. And that's going to end up giving me 2 root 2 over 3. Okay, so cos theta is 2 root 2 over 3. Great. I have to find cos theta over 2, so that requires a half-angle formula. So the way I set this up is I'm going to use the half-angle formula, and instead of cos theta, I'm going to replace it with 2 root 2 over 3. So the half-angle formula says, let's do plus or minus, which I know one of those is kind of useless, but I'm still writing it out. 1 plus cos theta, which is 2 root 2 over 3, all over 2. Now, one of the things that I don't need here is the negative. Why? Well, because this is quadrant 1. Cosine's positive in quadrant 1. So I don't need that negative there. Now, what I have to do is I have to get rid of the fact that we have a square root on the bottom. It doesn't look like I have a square root on the bottom because the whole thing's trapped inside a square root, but I have a square root on the bottom. I guess what I'll do is I'll multiply the top and the bottom by 1 over 2. That'll eliminate u. So this becomes distribute 1/2 plus root 2 over 3 after I simplify the 2's. Multiply that by 3, multiply that by 2, and I have 6 on the bottom. So I have 6 on the bottom. I have 3 plus 2 root 2. If I wanted to, see, 6 is still on the bottom inside a square root. So if I wanted to, I can write this out as 3 plus 2 root 2 up top, root 6 on the bottom. I can rationalize by multiplying the top and the bottom by root 6 over root 6. That gives me regular 6 on the bottom. And if I multiply a square root to a square root, I multiply that 6 to everything. So this is basically distributive property. 6 times 3 is 18. 6 times 2 is 12. Root 2. And all this is still living inside of a square root. So even though that's sloppy, that's my answer. Okay, a root within a root, that's fine. Don't be like, oh no, 18 and 12 and 6, they got to combine. No, because this is not a square root and those guys are. So complicated problem, very busy problem. But that's my guy. That's my answer. There you go.